Okay, in the previous section I mentioned that to state this, restart, semicolon, hit enter, will remove all the assigned numbers or equation to any letters or word, right? And it is really recommended to put these two lines in front of any maple files, because if you have some opened maple file other than this, and if you have done certain things in there, then even in the different maple files, still maple program remembers the results of previous maple file, which is already open, still open. So when you do this, maybe that results interfere with whatever you want to do here. So it's much better, or really necessary, to remove all these assigned numbers and equations from any letter or name. So from now on, whenever you need to make your new maple file or using somebody's maple file, still it's better to place these two lines in front of each maple file and run through that one. Okay, so let me click enter. Okay, so even I don't have any open maple file right now, but it's much safer right now. I know no letter or names are assigned to any number or whatever. In this section, we are going to cover 4 different commands here, and of course please read this. It's well explained, so I don't need to do this one by one. Okay, so let me just hit enter for each command line, and once again each command line comes with extra command line, because then it doesn't move that far, right? So it's very good. Now X is not assigned to anything, so W, capital W, is just the same as this equation. There are two ways to calculate this kind of equation value. One way is just we type the whole equation, comma, X equals 4. So we are looking for the results of that when X is 4. That's the command, right? Then it will give us 56. But if you already have a assigned letter for that whole equation, all you need is that letter, comma, X equals 4 will give us exactly same answer. Now you will assign another equation for W, and M is assigned to the results of that. But at this moment, our X is not just a number, but is another equation, so it will give you that results like this. So it's kind of composition with this function and that function, right? That order. And if you want to see the whole expand form of it, then you just need to use expand M. Then it will give you this polynomial style results. Okay. U is assigned to that, and evaluation of U from 7 to 12. That's the meaning of it, right? Okay. So this kind of you have a list of it, so you can calculate like this, right? So that's the meaning of it. So the eval faf we already covered, right? So it's changed to decimal. Equation even can be assigned to a letter. Okay, so this is the whole equation, and that whole equation assigned to EQN, right? So we can calculate it, okay, just for any specific number for x. So when x equals 3, this equation looks like negative 9 equals 0. So the meaning is what? The 3 is not the solution for this equation, right? Simply we know that. Okay. But when x is 4, it gives 0 equals 0, so we know that is the solution for that. 5 is not. Okay. So in this exercise, please try to answer these questions. Okay. There are 4 of them. Okay, next part is expand. We already used once in the previous case, but let's do it again. When k is product of these many terms, expand k gives us this polynomial style results, right? And sine 2x, actually we have identity in trigonometry. So expand will give you that results. For cosine 2x is to cosine square x minus 1, like that. So you could do it like that. If you have some fraction powers, okay, then it shows like that, and expand is really kind of multiplying one by one and arrange it like this. So the following exercise, please try to do this. Okay, the next one is factor command. If you have polynomial style one, whatever, you can actually factor out. And of course you can do all together like this. If h is assigned to this factored form, then expand of h will give us this polynomial style results. And if that is assigned to n's, then factoring that n's should give us back to the original forms. Of course, at this moment, even is factor out this quadratic equation, right? So if h is like that, then factor will give us this result. Or factoring for this whole thing is like this, because there is no factorization. Factor for this is exactly something square minus another square, right? So it's gonna be looks like this way. Even division looks like giving us as a fraction form. So factoring, it just factor numerator and denominator and give us like that. What happens if you have cancellations, like having common factors and numerator denominator? Then actually it's cancel out and giving us the simplest form of it. So that much maple is so powerful. Okay, once again, this case, let's factor numerator and denominator. If you really want to see the factorization of, because in that case we don't know what real factor is, right? It's cancelled out, so you need to calculate it. What is the factorization of numerator, right? That's so in this case, when you want to know the factorization of numerator only and denominator only, these are the commands, right? So numer is going to be the numeration of b, and denom is denominator of the given forms, right? So please do this exercise by yourself. The last one is simplify. Okay, let's say this is given form, and how about simplification of it? So actually it gives us some kind of factorization, and which is not actually easy in this case. You need to change this sine square to 1 minus cosine square, and sine to the fourth is sine square square, so it's 1 minus cosine square squared, right? So you have to pull it out and subtracting, adding, and factor out common factors. You need to change cosine 2x to something else. So anyway, this is going to be the simplest form of that after factorization. There is no more factorization, so that is enough. Okay. If m is like that, then simplification of that means putting together and maybe cancel out certain common factors from numerator and denominator. Please do this exercise.